Hi, everyone, and welcome. Thank you to Security Boulevard for hosting us today, and to our founder, Jeff Williams, who's been thinking fairly deeply about the topic of security automation. And if this is a topic that interests you and you want to go down this rabbit hole, he does have an article on D-Zone that just came out, and I'll link this to the bottom of the presentation. In terms of the topic and the goal for this presentation is a phased approach to security automation. Almost contradicts itself. Why phased and have automation at in the same sentence? Well, really, the goal of our company, the goal of Contrast Security, is to enable you to secure apps and software at scale. And the goal of this presentation is to show you a way to do that in a sensible, practical, and risk-based way. My name is Mahesh Babu. I lead one of the two business lines for Contrast on the protection. I'm focused on the protection side. In terms of the tone of this presentation, I'll straddle between the business and the technical. I lean towards the business in the beginning, and we'll go a little deeper as the presentation progresses. But I do want to caveat saying two things. One, I'm not a salesperson, so I'm not going to try to sell you Contrast, but I will use Contrast and the data we have to inform you on some of the topics that we're going to cover today. And two, I'm not a security engineer, nor am I our founder or CTO, so we won't go too deep. And if that is something that interests you, if you do want to go deeper, we'll provide some additional resources on how you can do that and go down that rabbit hole. Anyways, why don't we get started? In terms of what we're going to cover today, I typically structure my presentations across three dimensions. Start with the why, then move into the what, and then go into the how. The why will be fairly obvious to many of you listening to this, but it is important we level set on what is the problem we're trying to solve, so the solution makes sense. But hopefully there's some things in here that are non-obvious and just our take on what we're seeing in the market, and that's unique to us and our customer base. Second, we'll provide, once we know what the problem is, we're going to try to define the solution criteria of what good security automation is, and what are the dimensions that it needs to have to make you successful in rolling it out in your organizations. And third is how do you make that happen? And how do you make that happen using free tools available to you, and using the technology that we have in-house as a basis. The audience intended for this presentation, I'm seeing three groups of people who could get value out of this. One are AppSec or general security practitioners and budget owners who are thinking about automation as a way to get more security coverage across the applications or your portfolio of applications you have in your companies at scale, at the same time without disrupting the engineering process and integrating with the engineering process you have. It's an ambitious goal and has been an existential one as long as I can remember. We'll give you some practical tips on how to make that happen. Second audience are the auditors that test software level or application level controls on a year-to-year basis and are used to looking at scan reports and testing WAF or firewall configurations in a very traditional environment. And as the underlying technology you're trying to control changes, how are the controls changing? And with all these new evolutions, has the control environment degraded? improved, and what can some of the steps that I'm recommending here do to help you with testing, but also give you the assurance that not only has the control environment evolved, but it's gotten better and more continuous, assuming these steps are adopted. The third audience are the development managers. And if you are dealing with security in your enterprise, or you reach the point where security is starting to become an issue, and but you still need to ship, this presentation is for you. A little bit about me. I started my career at the Information Assurance and Security Institute at Purdue University, where I spent a lot of my time primarily doing two things. First, building out, working on a project called the Embedded Sensors Project, where the hypothesis was, can we get an open source version of SendMail, Apache, and Bind to detect and block SQL injections by itself, by writing sensors into the code base? Very relevant based on the company I work for today. The other piece I spent a lot of my time doing was building testing standards for biometric devices, facial recognition, fingerprint, retinal scan. My focus was facial recognition, but we had worked in a lab that built ISO testing standards for those devices. So that's where my journey with security started. Spent some time at Deloitte's security and privacy practice, but the meat of my career in security was spent as a practitioner at the third largest financial institution in the world. Was part of a team that reported to the CISO, that did special projects across the company. And one of my projects was helping build out the AppSec team and the risk assessment framework and the process that went along with it. So we had an application inventory of 87 applications within the largest region within the bank, and with limited to no assessment or testing coverage ever. And what we did was we used a mix of code reviews and static analysis to attempt to get that coverage. And as we went on that journey, in a year, we realized it wasn't scalable. Out of the 87 applications we had within that region, we were able to get through 10. We tested 10 of those applications, and we remediated 0 vulnerabilities. There had to be a better way. All this happened in the city of Chicago, where HSBC's global IT organization was situated, and I've been a long-suffering Chicago Bears fan since. Spent some time out in the business world and in business school, and before coming back to security and as part of Symantec's pricing strategy team, and then finally made my way here to Contrast Security, because I believed we had found a solution to a problem that I had as a user at HSBC, and I believe for the first time, it was a company that figured out how to do application security at scale. So jumping into the why. Why is security automation important? If you think about us as AppSec vendors, the core of the problem we're trying to solve, and for all of you as practitioners, if you were to boil it down to one thing, the one key problem that we're dealing with as a community, as an industry, it's this. Our businesses have to deliver 10x more code, or orders of magnitude more code, while protecting the integrity of the business. There are two key things there. The amount of code being delivered is more than ever before, and the importance of securing that code is more than ever before. And why is that? So let's unpack the first part. The second one is obvious, but let's unpack the first part. The rate of production of code, however you measure it as a software development shop or as a business, number of applications produced per year, the number of releases produced per quarter, number of lines of code per developer, number of lines of code per release, number of releases, whatever the key metric, there's an exponential rate of change compared to what it was 15 years ago or even 10 years ago when I was at HSBC. I think it's fairly obvious if you're on this webinar, you know why, but we'll level set on the why. And my hypothesis coming into this company there's a misalignment of spend. There's if you look at an average CIO's budget, 40% is software, 37% is software. Right? But if you look at a CISO's budget, is 37% of a CISO's budget spent on securing software? Probably not. You're spending that money on infrastructure protection, or you're spending it on email or DLP or IDS or your SIM. So I thought it was that misalignment of spend. But then the big realization our customers told us was it doesn't matter. Even if the spend flipped and suddenly 40% of a CISO's budget was spent on security, I don't have enough people in the market who have the expertise to do this. There's a massive, not just talent shortage, there's an expertise shortage that doesn't scale. And there's a tooling limitation that doesn't scale. And that is what is causing this massive gap between the amount of code being produced and the amount of coverage, security coverage against that code, leaving this massive residual risk that keeps increasing over time. Make sense? Agreed? Okay. So let's unpack that rate of change of code. What's causing that? Yeah. The path from developer to app has fundamentally changed. I think we all agree to that there's this move from whatever is the business driver is, whether it's a digital transformation or whether it's investment in DevOps or whether it's the need to respond to customers faster, whatever is underpinning the change, there's a fundamental change to the way software is being produced in enterprises across the board. So we're going from a waterfall model where you're releasing once a year, you're releasing once every 3 to 6 months, using a serialized process of dev, test, functional test, QA, staging, and then production, to now you're going 2 to 4 weeks. You're using an agile methodology to build MVP, a minimum viable product, and then quickly getting feedback and iterating it over time. Now, think back to what I told you we did at HSBC. We used a mix of manual code reviews and static analysis scanning. The average time for us to take a large business application and run that process was about a month. A month was painful enough at HSBC where depending on the app, we released every 6 months or every year. You're adding 20%. You're delaying the release by 20%, or you're adding 20% more time, which was painful enough. Imagine applying that process to an agile shop that's releasing every 2 weeks. How does a month-long static analysis scan or a code review stack up when your release itself is only 2 weeks long? So that process doesn't work today. So we talked about an expertise shortage, not enough people who understands both applications as well as the security of applications, but the tools out there don't scale and don't meet the needs of this new paradigm. A 30-day scan or code review doesn't work in a 2-week cycle. The second big thing that is really accelerating the rate of production of code is a lot of the software is no longer built by you. The rate of use of third-party building blocks is more than ever before. And all it takes is one of those parts in the supply chain to have one vulnerability that hasn't been fixed to expose your entire application. One of those parts are vulnerable, your whole app is vulnerable. And what's worse is you don't have the fix to that problem unless the exploit's disclosed, publicly disclosed, the patch is publicly disclosed, and you have the visibility into which of your applications are using that component, a vulnerable version of that component. You know how to fix it, and you have the bandwidth to take that application down and fix it. But all that before you get breached. What I described across an enterprise of hundreds of applications is at a minimum a 6-month exercise. Think back to what happened to Equifax in 2017. They were breached within 75 days of that exploit being disclosed. Operationally hard issue, right? So we talked about, before we move on, we talked about 3 key problems. 1, there's an exponential rate of growth in the amount of code being produced, and there's a shortage of expertise to secure that code. The existing scan-based tools and code review processes don't really scale at the rate at which code is being produced. And third, the use of open source components, third-party components to build your app is exacerbating that problem, because all it takes is one vulnerable part to expose your entire application and your entire business. And what does that mean to the average application? It is extremely vulnerable. This is something, this is the data we see within our environments. Our average customer's application is composed of 70%, 79% third-party components. So only 21% of the app that our average customer has, they built themselves. The other 79% are third-party components. They pulled off of GitHub. They're pulling off of other well-known open source repo, or they're purchasing from somewhere else, or in licensing from somewhere else. Now, out of that 79%, only 8% is used, but only 8% is used, but all of it is vulnerable. And this is what we see across the thousands of applications we we test and watch on a day-to-day basis. The average application has 28.7 vulnerabilities. And those applications are constantly under attack. The other piece to it, so you have these applications sitting out there, shipped into production, and are constantly seeing attacks. On the right-hand side, the 2 graphs, you see are from our environment. These are real customer applications, and these are attacks we saw in the last month alone. SQL injections, path traversals, and cross-site scripting being the biggest source of attacks as a percentage of the total number of attacks we see. And as you can see, SQL injection, 80% of our apps that we cover see a SQL injection attack. A little under half of the applications we cover see a path traversal, and a little over a third of our application that we cover see a cross-site scripting. 5638, the OGNL exploit that affected Equifax, still fairly popular. And by language, the SQL injections are constantly being seen on Java applications. XSS is fairly common in .NET, and path traversals being the biggest one for now. So the net is this rate of change of production of code, exacerbated by the use of open source libraries and unscalable tools, and very little time, developer time to fix, has left this latent risk out in applications. So applications are exposed to these risks as they're running in production. Which brings me to the third issue. This is a fairly unscalable problem. Knowing the vulnerabilities is not enough. If it takes you on average 38 days to fix a vulnerability, and not a lot of time is being spent in a release cycle fixing these vulnerabilities, you have this latent risk. And that's why you build your application. Once you ship it and you run it, the controls are misaligned. If 79% of your code are libraries, but you don't have protection rules defending those vulnerable libraries, and your app is built on API, but no one's protecting the API calls and just looking at HTTP sources, you have a latent risk. And third, if you do get breached, there isn't enough context to really respond to these attacks. How many people today know when an attack happens on an application, on a layer 7 level attack happens, which application the attack is on? What line of code is being exploited? Which function is being targeted? Which library is being targeted? And is the application vulnerable to that attack? Most of the time, the answer is no. So net, the problem exists. If we were to summarize the problem, the rate of change of code is more than ever before, but the protections aren't scaling with. So what that leaves you with is a massive amount of latent risk, residual risk in those applications as they run, open to be exploited, and they are being exploited. But your protections against those applications aren't focused on the right things. So this is why security automation is key, because this is not only a security problem, it's a scale problem. So what we need is automation to be a force multiplier to solve the problem. So Jeff, our founder, boils it down to 4 key things. This is where we transition from the why security automation into the what is good security automation. There are 4 key criteria that makes security automation, that makes good security automation. First, it's accurate, because this is where simply building a real-time integration into a CI/CD pipeline doesn't solve the problem. If you are generating, if 80% of the findings you generate as a security vendor are false positives, and you're automating the delivery of those results left into a developer IDE or into a case management system, you are just taking that, you're just dumping that data into a different view. You're not making people's life better. You're just dumping that data into a different view. So the signal to noise ratio reduction is really, really key. And that's where security automation is only successful if the data being provided is accurate. Second, it needs to be real time. So the right alert at the right time to the right person. And as much as possible, it parallel processes along with the other activities you're doing within the development lifecycle. You're not adding a step, you're working in parallel. Third is it's continuous. If you are using an agile development lifecycle and we're shipping code every 2 weeks, the app is always changing. So having a point in time scan doesn't give you the real picture of the risk. It gives you a false picture of the risk, because the moment the next line of code is written, that set of results from the last scan you did isn't relevant anymore. And fourth is reliable. The automation reliability becomes very, very important if you're embedding the automation into an operational environment, into a production environment. You have to ensure that automation does no harm to the application, doesn't impact latency, doesn't impact reliability, doesn't impact the stability of the application, and at the same time is able to provide real, reliable, accurate data to ops teams and to security operations centers and to developers in a way that's actionable. So the 4 key, what makes good security automation? It's accurate. It's not just dumping the same results, same inaccurate results into a different source. It's real time, works in parallel, not a serial additional step. It's continuous, so it's always on and not a point in time. And it's reliable and performant and stable and does not impact the day-to-day operations of the app. So our internal hypothesis is that to have good security automation that has those 4 key things means a move to an embedded approach. What do we mean by embedded? So let's start with what we mean by not embedded, which is a scan and firewall based model. So we talked about some of the limitations to a scan based model. It's outside in, it's resource intensive. It doesn't scale with the rate of production of code. It's not accurate. It's disruptive, and it's an additional step in the process as opposed to being parallel. It's not accurate, not continuous, not reliable. Whereas an embedded model is an inside-out, sensor-driven model that allows you to work in parallel with the rest of your development process. Scales protection across those applications without adding headcount. gives you instant feedback and is not a point in time. It's always on and works across your development cycle, whether you are working in dev, QA, or production. So if good security automation is accurate, point in time, continuous, and reliable, the way to deliver security automation, we believe a good way to deliver security automation should be an embedded one. So what is the tech that can enable security automation? This is where I'll introduce our approach to the problem to automation. And so I'll provide a disclaimer here that this is the way contrast security works. And we're using our tools as the basis to explain embedded tech for security automation. So that's my disclaimer. And the two pieces of technology we use are called IAST, Interactive Application Security Testing. When operating in dev and QA, we use a sensor-based approach, an embedded approach to detecting vulnerabilities as you build your app. The beauty of the embedded approach here is because of what we watch, we can watch not just the code. Not only do we do a full binary scan of the code when the app starts up, but we can watch how the code interacts, how data interacts with the code and goes from the HTTP source to the sink, and really confirm whether something is a vulnerability or not. So coming back to the dimension of being accurate, you're not only telling someone when a vulnerability is real. The beauty of this approach is it also allows you to do it in real time, because it's the app that's confirming the vulnerability itself. You're not doing a separate scan to identify this. The second piece of it is runtime application self-protection. Once you've found a vulnerability and you ship your app into production and the vulnerability hasn't been fixed, RASP allows you to prevent attacks against that vulnerability. Again, the value of this being embedded into the application itself is you can confirm whether an attack is exploitable or not, because you know what the vulnerability is. You know what your app is made of. You know what components it has. You know what vulnerable components it has. So when you see an attack, you know if that attack is against a vulnerability that your app has. So if you see a SQL injection attack and your app doesn't use SQL, the embedded sensors know that's not an attack you need to worry about. The other benefit is this kind of approach also enables you to protect yourself against classes of attacks, whether it's known or whether it's a 0-day, because this isn't looking at a signature or looking at an HTTP request and trying to pattern match against known types of attacks, but it is looking at the behavior of how that attack interacts with your application and confirming whether a bad action is truly happening before it's prevented. So the benefit you get is you're making your app through security automation smart enough to find the vulnerabilities it has and protect itself against those vulnerabilities. That's good automation. And it's doing this in a way that is accurate because it's in the application itself. It is point in time, real time, and it's not based on an outside and external scan. It's continuous, it's always on. As long as the app is running, it's running, the automation's running. and it's reliable. So it's performant enough where it's not breaking the application or changing the behavior of the application. So how does this technology work, or how do we as a company approach this? Uh, the sensors are embedded into the application. The automation is embedded into the application using a technique called instrumentation. Java came out with this technique back when it introduced its bytecode instrumentation API. Works a lot like any application performance management vendor you've heard of, New Relic, App Dynamics, Dynatrace. Um, we use the same technique, but we use it for a different purpose. And what's unique to we can say we're not the only IAST and RASP vendors in the market that use instrumentation, but what's patented to us, what's unique to us, is how we instrument and where we place those sensors. The depth at which we place those sensors are unique, truly unique to us, and it's that data that we're able to mine and the decisions we're able to make based on the data that make us unique. And I'll pause the sales pitch there. But the benefit, net, the benefit of the instrumentation approach is it allows you to embed the automation into the app itself and give you all the benefits of security across the CI/CD pipeline, across your development lifecycle. And you're not just finding the other benefit is you're not just finding vulnerabilities in your own code, but in the libraries that you're using as well. And if 79% of your app is are libraries, and all it takes is one exposed library to cause a breach, that's critical. And if you don't have developer time to fix those vulnerabilities, all the more critical. Moving on. A quick example of how you find how a vulnerability looks and the benefit of what you get from being inside the app is you get things, you see what the actual parameters that could be exposed. You can see which line of code and which function the can cause the vulnerability and what it actually does to the application at the sink. This is the kind of context you get and details you get that you can provide to a development team to very quickly go fix or turn on protection for. And all this without ever sending your code anywhere to get scanned. This happens. This is the app self-reporting on these things. On the attack front, similarly, you're not just looking at the IP address or of the attack and the attack string, but you're getting information on what part of the attack string is actually causing the issue, and whether you're truly vulnerable to that attack or not, because you know what your app is vulnerable to. If the automation knows what your app is composed of, it knows whether the attack is effective or not. So this example is when the Equifax 5638 exploit came out, we saw a lot of attacks on ourselves, on our contrast web apps. But we knew that those were probes and not real exploitable attacks because we didn't use that library. We didn't use the struts2 library that this exploit is trying to take advantage of. So we saw a lot of struts2 attacks on ourselves. We didn't use struts2. So we knew but to ignore these attacks. So, and the average, when we look at our customers' applications, 84% of the attacks we see are these kind of ineffective attacks. And what an embedded approach does, sales pitch aside here, is it allows you to focus on the attacks that are real. And it avoids a number of investigations that could be deemed critical if you didn't have this level of context. And if you do bring the security operations center or your ops center, if you're using Splunk to monitor your app in real time, this kind of data is really, really valuable to them because now they have context and they know how to prioritize and they know what to ignore. And you're giving them, if there is a real exploit or there's a real event, you're giving them enough context beyond just the IP address and an attack string. You're telling them which app, which function, which instance. So you can be very, very targeted in the incident response process. So how do we build this in? Start with what it looks like, what the full picture looks like. Instrumentation manifests itself as an agent. That's how we do it. But the term agent is misleading. It's not an agent in the same way you think about an endpoint security agent. We call it is. Let's take the example of a Java application. It would be a .jar file. A .jar file that is dropped into your source code package along with the rest of your app, and is, as long as you start your app, you boot your application up at startup with that jar file, it just works. Now, the first question is where do you deploy it? You can do it in 3 places. You can build the automation into dev. So as developers build their app, you're giving them real-time feedback into on what vulnerabilities they're creating, and you're giving them feedback on which lines of code they need to go fix, right? Second is you can put it in QA. So every test, every functional test, every integration test, every regression test that your dev teams, your QA teams perform becomes a security test, because every time the application is exercised, the automation finds the vulnerabilities and sends it in real time to either the teams collecting the test results or directly back to the developers. And third is, now that you have a full picture of your app, of your vulnerabilities, now that testing's done, but you know that developers don't have bandwidth to fix or patch those vulnerabilities, but you still need to ship into production. That's where the automation gets pushed into production, and all this, and you have protection against those vulnerabilities. The way Contrast approaches the problem, all 3 steps is the same .jar file. It's the same agent. You don't change a thing. The only thing that changes is when you go into production, you license RASP separately, and that's automatable too. And you'll soon see with the free version of the product you have, you don't have to do that either. It all comes turned on. In terms of taking a risk-based approach to this, putting my security hat on, if I was to roll this out at my former employer, where I would start, my recommendation is to always start here with QA. The reason why are 2 things. One, it gives you the maximum amount of coverage in the shortest amount of time, assuming your applications go through a fairly standard QA process. It allows you to get a full picture of your risk across your application. Is by then the assumption there is that you have a more fully baked application compared to what it would look like. The pieces of code of the code base would look like within a developer desktop. So a great starting point is there, and the third benefit is you can very easily, with this kind of automation, build into your integrate into your test automation environment. So if you're using Jenkins, it's very easy to put in a criteria that says fail a build if you have X number of critical vulnerabilities, and that becomes a forcing function for your QA teams and your security team to go talk to your developers to say, here's your build failed, and here's why. And that prompt will prompt the conversation to say, well, I wish I knew about this earlier. How do I know about this earlier so my build doesn't fail and I'm fixing these things before I even check in my code? And that allows you to transition into pushing the security automation left towards the developer desktop. Same agent, just offered up to the developer desktop. And if you're using contrast, um, they can they can very easily get those results um, from contrast directly in their IDEs of choice. So whether that's Eclipse or IntelliJ on the Java side, or it's VS Code or Visual Studio on the .NET side, now have to leave the desktop, the IDE that they're using to build code, um, to build their app, to be able to get those results. And also there's opportunity to hook into the repo environment that you're using and look at the vulnerable libraries that are being used and assess the risk against those as well. And the third step is once the application's been tested, the vulnerabilities are either fixed. There comes a choice. Not every vulnerability is going to be fixed within the time of a release. The average amount of time it takes to fix a vulnerability is 38 days. That's the industry average. Your average release cycle in a CI/CD environment is 2 weeks. So even if you're finding these vulnerabilities now at scale, you're not going to be able to, the developers don't have all the time in the world to fix them at scale. So you're left with a choice. You can stop the release, and you can push the developers to go fix the vulnerabilities before you release. So you can delay the release. That's number one. Number two, you can accept the risk and say, I know this is a risk. I'm still going to ship, and I'll get to it. Or my engineers will get to it when they in the next cycle or whenever they have time next. Not really practical when it's an open source library or it's a massive undertaking that, when weighted against a revenue generating feature, is never going to get the time of day. So you need to have a third option, and that is automating the protection against these vulnerabilities in prod. And that's where the RASP component comes into play. So if you have automation that allows you to shield your app against those vulnerabilities, that knows what your app is vulnerable to and shields you against those, the work is done. Your developers can move on to the next thing. You have the control in production, and your vulnerability is remediated. And in addition, the added benefit is, with contrast, the way our RASP works is because of how we detect these attacks in a non-signature way that's looking at behavior, that's looking at sensors across the stack and watching different things before we make a final decision at the sync. We also have protection against zero-day attacks out of the box. But regardless of which you go with us or you go with another way, another instrumentation-based approach, this is critical. This is how you embed security automation into your CI/CD, and you're able to get this level of protection, both testing coverage as well as protection coverage at scale. We strongly believe in this embedded model. And so to recap, where do you start? What is the phased approach to building this in? Step one, start with your QA environment. Use that because that's where you get the full picture of the application as well as the full picture of the risk. That's also where you have the strongest, you can have your quickest win, because you can use your Jenkins or your test automation process as your forcing function to fail builds and use that to communicate um, vulnerabilities back to engineering teams. And then use that as a hook to step two, which is embedding the security automation into the code base that goes into the developer environments, into the developer desktops. And then third is eventually, once the developers have a full picture of what their vulnerabilities are, you have a full picture of what your risk is, and your understanding of what can be fixed before something is shipped, then you come to phase three, which is pushing this automation into production and turning on RASP capabilities, or protection capabilities. And so step one, deploy in QA and fail builds. Step two, push to developer desktops. And step three, turn on protection in production. Deployment's easy if the model is fairly similar to contrasts. It's usually a library or jar file that can be added to any application startup scripts you have. There are command line options, there are YAML options. Because it's a single file, it's fairly configurable. And on the production side, the beauty of this approach is it goes where the app goes. So it's workload agnostic. Whether you're on AWS or Azure, or you're in a private data center, you're in a VPC, it doesn't matter. Wherever the code package is, yeah, the automation will be there with it. And that's especially true for us. And the answer to any question your development team or your ops team has about compatibility is always, yeah, it works with X. Because it's specific to the code and it's not specific to the infrastructure. That also means there is a limitation with this approach, to be perfectly honest, which it is tied to the code base. So if you have multiple languages, you have to build the automation that is language specific. So that is the caveat, but it is infrastructure agnostic. That's the beauty. And last but not least, it becomes fairly simple to get results where you want it. So whether you want it as a Chrome extension, whether you want to deliver it to a developer desktop, or you want it in Slack and in a chat ops notification, wherever developers consume this information is where you need to integrate the automation into. That's the key thing. And with the contrast products, you get these integrations out of the box. And the beauty of it is, if you choose to go down this contrast route, there are multiple routes you can go down where you have a set of IAST and RASP vendors that you can work with. Contrast is the only one that offers both. It's number one, and offers both for free, number two. So if you want to try us as a way to whet your appetite, or proof of concept within your environments, you can do that without talking to a sales rep or without talking to anybody at the company. It's fairly self-service, but the best practice in terms of doing this is really taking that phased approach. And once you have the automation built in, you have the agent installed across your environments, it becomes really, really simple to scale it to multiple environments. If you solve your base case of one, taking it from 1 to n becomes fairly simple to replicate. And like I said, you're welcome to start for free today. As part of to conclude this webinar, we'll provide a link to our community edition version of the contrast product that you can download for free. And it's a fairly simple self-service install. Try it on a sample application or within one of your applications within your environments, and see it work. Like I said, start with your QA environment where you have a more fully baked application. Use that to build in the test automation, which is also all those integrations, our Jenkins integration, our ChatOps integrations, our Jira integrations, our Splunk integrations. All that is available to you for free as part of this solution. Um, and then send it to the developer desktops. And if and once that's done, try it in production. So that's the process with contrast in general. But whether you choose to work with us for a longer engagement, or you choose to use this as free forever, I would strongly encourage you, try this. If you are thinking about security automation and you're thinking about tiptoeing into it, and starting to get some coverage over this exponential growth in um, software development that's happening in your companies, this is a good place to start, whether you end up working with us or not. This is a great proof of concept idea, and we want this in the hands of as many people as possible, because we're out there to solve the problem. We're not doing this. The community edition product is not about generating revenue. It's about generating awareness of this problem and getting people to buy into the idea of security automation, and proving that it's easy to do. It's not overwhelming. It's not insurmountable. And that will hopefully allow you to build a business case for a more enterprise grade solution down the road. If that is something you want to go down, or something you want to script out yourself, that's also. Now, what we covered in this webinar is just scratching the surface. We have a thought leader in this space working for us that founded this company, Jeff Williams. The timing worked out that Jeff wrote an article for DZone on this topic. And if you want to go deeper and really learn from a technical expert about how to operationalize security automation at scale in your environment, and you would like to go down this rabbit hole with us, Jeff's article is probably the next logical step. And last but not least, if you are an auditor and you want to understand two things. One, what does automation mean to the control environment? If it isn't clear already, this approach is continuous. So you're moving your environment from being a manually tested environment to a continuous, always on environment. But if you have questions about what does that mean for coverage, what does that mean for anything prescriptive that's in something like PCI or SOX or GLBA, we have a position that we've validated with Coldfire, the largest QSA, the largest PCI auditor in the United States, that tells you how specific standards can be met, and how using an automation-based approach, using an IAST and a RASP approach, can help you achieve PCI in a more continuous and real-time, accurate, and reliable. That's all I had for you today. In summary, why security automation? There's rapid growth in the amount of code being written, driven by the use of agile development. There aren't enough security experts to scale to cover that code, nor are the current scan-based tools set up to be able to cover that. And to exacerbate that problem, the amount of use of open source libraries are more than ever before, and all it takes is for one vulnerable component to expose your entire application. So to be able to address this problem, there needs to be a force multiplier. Security, we believe, an embedded approach to security automation is that force multiplier. But good security automation has to be accurate, it has to be real time, it has to be continuous, and it has to be reliable. And IAST and RASP are the two technologies that can be offered in an embedded way to automate security within your applications. Of which we believe Contrast's approach, Contrast is the only solution that offers both with the same agent, with the same technology. And we believe in that approach enough to offer it for free. And it's available for you today at contrastsecurity.com/community edition. And finally, if you want to learn more about automation, please check out the articles linked as part of this webinar. And if you want to learn about how this can help you with your PCI posture, please pursue that as well. Otherwise, thank you for your time, and we look forward to working with you in the future.